Okay. All right, let's try and do a crash course here, Rover. Since you already learned this in tutoring anyway. Oh, the booklet's there.
No, tutoring doesn't count. I told you 8,000 times.
You have, the notes look pretty good from what I saw from your tutoring.
Yeah, but I didn't
Pay attention to it?
yeah, the counts was a bit much.
Okay. All right, let's see what I can do in half an hour, because that's... all right, so basically simple harmonic motion is like when you have any motion that's just oscillating. It doesn't have to be pendulum swing, but it's like your typical example. Another example is like a spring. Obviously, it's oscillating. So it's going back and forth from the same spot back and forth. And what happens is if you actually graph out the motion, it ends up either becoming a cos graph or a sine graph. It can be either. It just depends on the position where the object starts moving. So a few facts that you got to know. So taking simple harmonic motion as like the example, the extreme position is like right at the end of each side. This is obviously the center of the motion. Extreme position, let's just, for the first example, we're analyzing, so let's say the motion, if you graph it out, the displacement, that's that. So what you'll notice, the extreme position, if it's on the left-hand side of the center of the motion, it's minus 4 meters or centimeters. On this side, it will be positive 4 meters or centimeters. Now, on this side, so if you have a look at the pendulum swing, let me just stop it. Like if you, from there, like, have you done physics?
No, I probably know everything.
Yes, so here, obviously the speed is 0 because that's the start of the motion, that's when it's going to be released. But the force, as soon as you release it, it's the fastest at that point. So at this point, velocity is obviously 0, but the acceleration double dot is the greatest. So the potential energy is at its greatest. So it's obviously fastest at that point. But here, when we reach the center of motion, which is 0 meters in this case, but next lesson we're going to look at a case where the center of motion is not 0. The speed is the greatest at that point, because it's like that's this. But here, the acceleration is actually 0. Here, the speed is also 0, so it's the same thing, and the acceleration is the greatest. So these are the facts that you got to know. So extreme positions, these are the features. Okay, so based on that animation, I think it makes sense. I'll just pause it. All right, so we're going to look at the first example. So basically, they want you to analyze the motion of this. So what we want to do is derive it and get the acceleration and see how they're all linked. I feel like I'm doing like a YouTube crash course like in 5 minutes. So if I differentiate this, now like I said, usually they use cos, but it can be sine. There's no right or wrong starter. It just depends on what they give you. So if I differentiate this, that's 8 cos 2t. And if I differentiate this again, now try and avoid using a for acceleration because we're going to actually use a for amplitude. So we don't want to get things mixed up. This is minus 16 sine 2t. Oh, one more thing though. Hold on. There is a feature I need to teach you. From here, just for velocity specifically, if we square it, that's 64 cos squared 2t. What I'm going to do is now replace this. Yeah.
I'm at school. Oh, okay. Thank you so much. No, I was just my casual way. Bye.
What was that?
I
Okay.
know how you were asking, like, in general, if we're coming. She thought I was still sleeping.
Good question. Wait, hold on. Shit, is that recording?
Yes.
Okay, good. So I saw it's okay. I won't publish it. No, make it unlisted. From here, now this though, what we want to do is actually from here, if I make sine 2t the subject, that's x over 4. So this is actually the same thing as writing x squared over 16. And from here, if I take 16 out and write it like without the fraction, what you'll get is actually 4. And then you get 16 take away x squared. Is that all right? Because making 1 over 16. Now, the reason why I wanted to write it in this form, there's a feature to come out of this. So first of all, like graphically, going back to year 11 trigonometry, this is the amplitude, right? And this is your n to find the period. What you'll notice so this, you're going to have n squared here. That's a feature. And this is the amplitude squared. So in general, you've got to remember this formula. V squared equals to n squared a squared minus x squared. So this is a very useful formula if I want to link velocity in terms of displacement rather than just time. So it's like that, last lesson we learned the acceleration, I'll write ACC not to get confused with amplitude, is the same thing as, was it dt or was it half v squared? It's d over dv, right?
I think so.
Yeah. So so it's the same concept. So if I want to ever link this velocity with displacement instead of time, that's a very useful formula. Another good thing that comes out of now, even for acceleration here, what you'll notice.
It's dt.
Is that dt? Crap, I forgot. Hold on, let me look back. It's a very simple formula. D over d. Oh, sorry, it's d over dx. Oh my gosh. Yeah. So if I want acceleration in terms of velocity and displacement, that's it. Well, it's a similar thing here. Now with this one, you'll also notice this is actually a squared, the amplitude squared. Yes. So the acceleration in general. Oh crap! I forgot. Sorry. It's actually n squared. Wait. I'm supposed to get minus n squared x.
Yeah, the formula I remember is minus n squared.
Yeah, n squared. Wait, how did they get n squared?
No, the n squared is that one. Yeah.
Hold on. Wait. Oh, wait. Sorry. This, in terms of x, is minus 4x. Yeah. Because you know how, just to make it clear for the video, this is technically the same thing as minus 4 times 4 sine 2t, and this is x. So, but the 4, so it's actually minus, the formula is minus n squared x, if I'm correct, Okay, so this is your acceleration formula, and this is your velocity formula in terms of displacement. Okay. So in general, I'm just going to summarize it because trying to do a crash course here. They usually use, like I said, cos for the displacement, but once again, it can be sine. Nothing wrong with that. So in general, that's your displacement formula, where you could have an angle in there as well. Okay. And then velocity or x dot is, if you basically differentiate that, you're going to get minus. I should derive it. Hold on, how did they get just nt? Where did the alpha go?
You don't need. Oh, okay.
Alpha can be 0. It doesn't. You know what? Fine, I'll derive it. I was trying to. Okay, fine. I'll just derive it. Okay. So then that means x dot is minus an sine nt plus alpha. Okay, and then x dot is then minus an squared cos nt. So I'm just deriving it. So, but remember, this can be written as just minus n squared x, which makes sense because you got the a and you got the cos, and that's exactly what x is. And v squared, they just squared that. I'm not going to go through all that working out, so it's just that. Though, that's basically what you need to know.
How did they do that? And before you derived it, it was just nt without the plus alpha.
Yeah, I think that's a condition where.
Alpha 0.
Yeah, because you don't necessarily always have to have an angle, just like that example. Okay. Oh, and just another thing, just forget T is usually the letter that they use for period, and I don't know if you really need this, but the frequency of The frequency is the number of oscillations per unit of time. You don't really need that. Just thought I'd put it out there, but this is the main one. Okay, I think that's all the boring stuff. All right, now let's get to actual examples. Example 6. All right, there's actually not much for me to go through it, but I just wanted to point out, if you look at example 6, discuss the motion of the particle. I really didn't like that type of question before, because it's like, what do you actually explicitly need to mention when they ask you that in the exam? So when they ask you discuss the motion, what you need to point out is basically, if you look at the final answer, what they want is what's the amplitude, what's the period, and initially, what's the velocity, and where does it start, and what's the acceleration. So if they ask you for discuss the motion, basically analyze everything, which is not hard, but look, just as a rundown. So if you got this, the amplitudes are obviously 4, so that's your extreme positions. The period, it's just 2 pi over 6. Initial velocities when t equals to 0, if you sub that in, you'll get 4, which means it starts 4 meters to the right of the motion. Just got to be explicit with those things. Velocity, you know what to do. Okay, so those are the things that you need to point out. Okay, can I squeeze in example 7 here as well? Just trying to save time here, because there are 12 examples. 12, okay, motion of the particle. So this time, we've got d squared x is equal to t squared equals to minus 16x. So what you need to first be able to spot out is actually acceleration. Okay, because it's d squared x. You're differentiating displacement twice. So you want to write it in that form, because as soon as you write it in that form, I don't even know what the question is. Before I get to that, like you can already tell right there just by looking at that. Yeah, n equals to 4. And then now let's have a look at what they've given you. So if x equals to 0, v equals to 4, so that's basically initially. Find its displacement at any time, so find the displacement formula. Okay, yeah, all right. So from here, so starting with, like I said, you'll get the same answer, I believe, whether you start with cos or sine, you should get the same answer. But in general, they just always use cos. So from here, so for n equals to 4, that means you've got a cos 4t plus alpha. Okay, so that's your x. And from here, what can I use to find like other knowns here? Well, they've given you the initial conditions here. So when x equals to 0, you got a cos 4t is gone, so it's just alpha. A is gone because if you divide it, so basically alpha is...
Isn't it v is equal to 4?
Sorry?
V is equal to 4, not 0.
This is displacement.
Oh, displacement.
Yeah, x. What's cos of 0? It's meant to be pi over 2. I'm trying to find alpha. So where the graph starts from... Right. What's shift cos 0? No, it's 90 degrees. Because if you look...
Oh, sorry, yep.
Yeah, so when it's 0... Wait, how do we get 90 degrees again from graphically?
The B,
When cos... Wait, it's asking for these angles, sorry, yeah. So the first angle when the y value is 0 is pi over 2. Or just use a calculator, yeah? Shift cos, you'll get that. Okay, so we have that, and then basically, if I differentiate it for the velocity, that's minus 4a cos, sine 4t plus pi over 2, and then use those two conditions to find your a. That's not hard. Okay, right, take a photo and let's see how much we can do in the next 15 minutes. Continue working on this example though. They do have like a final form of the equation a bit neater, and just have a look at that. So for your trials, I plan on assessing you up to simple harmonic motion. We're going to spend 2 lessons. Simple harmonic motion is what, 2 lessons worth?
Oh, so just this term or something?
Yeah, because then if it's not, that's what I'll be ending with. Unless you want me to go through more content next term. All right, so example A. So once again, they've given you this. Find its period, amplitude, and displacement, given that when t equals to 0 initially, x equals to 3, velocity equals to minus 6 over root 3. I don't know what's hard about this. So once again, that's your n squared. So n equals to 2. Can I skip that? Because basically the same steps. Yep, the only part that you need to pay attention is to find alpha. If you look at the working out, they actually had to divide the 2 equations to find alpha. So just have a look at the example. I don't think it's hard to understand. Okay? Yeah. Okay, all right. This is a different type of example now. Okay, that's not hard. Example 9. So this time they've given you the velocity equation, but in terms of the squared version. Okay, with the magnitude, blah, blah, blah. Show that the motion is simple harmonic. So if you want to ever prove that the motion is simple harmonic, what I should have mentioned is, you know how the acceleration is minus n squared x. So this is basically what you need to show if you want to show a motion is simple harmonic. So in terms of words, simple harmonic, the acceleration is always proportional to the displacement. Because you know how going back to year 9 maths, you know how it's like some kx or something? Yeah, so n squared is like your constant. So in order to prove something simple harmonic, you need to get to that. So in order to do that, well, we need to actually now use that. So that's a very handy tool. So, well, first of all, we need to get the expression for half v squared. That's 3 plus 2x dividing everything by 2. And then from here, now what you want to do is you want to differentiate this with respect to x. And if you do that, you get 2 minus 2x. So that means, because you know how if we're differentiating a velocity equation, that's acceleration. So right now what we have is then if I factorize it, I have this. Oh, so it's taking the minus out because we want the minus out. So that means I have then x minus 1, like that. And then from here, I'm not done yet. I've gotten this part, but I need to somehow prove. How do I do that? Hold on. So we've got that. Now with y, because you can just do that. Oh, that's so dodgy. You know what they've done? They literally just replaced this with a letter, in this case y, and they just literally just ended it with hi, Ma. They literally just ended it like that, and they said it's therefore a simple harmonic. I guess you could do that. As long as you have the number factor out with x expression, I guess that's basically all we need. So, yeah, so don't be confused why they just created the y in the example. Okay, so basically from here, so what do we know from here? What are they asking for? The center of the motion. Okay, yeah, with this one, the center of the motion, it's not 0. It's x equals to 1. Does that make sense? Yeah. So center of the motion in this case is x equals to 1 because of the bracket. One way to confirm that is, you know, at the center of the motion, the acceleration is 0. So obviously if you just plug in 0 and then you find what x is, that's x equals to 1. Okay, if you have a doubt that? Yep. The period How would I find the period? Well, I know from here n equals to root 2 because of that. And that means the period t, all you need is n to find the period. So that's 2 pi over root 2, which is pi root 2. Okay? The amplitude, though, amplitude is the extreme positions. Okay? You don't necessarily always have to go back to the displacement formula. So how would I do that? Well, using this, using the fact that velocity is 0 in extreme positions, we can find out what x value is. So it's just basically the quadratic formula. So 6 plus 4x minus 2x squared. Go through your factorization using, Gross method or whatever, and you'll get that. Okay. So what that basically means in this simple harmonic motion, so one's like your center of motion, and then it's oscillating between -1 and 3. Yeah, and that makes sense because you've got 2 units back, 2 units forward, 2 units back. Yeah, just like that. I thought that was a good question. Example 10, just don't like the way they laid it out. Example 10, the first example is show that 3 cos 2t plus 4 sin 2t equals to that. I don't like the working out. You just have to go back to our 3-unit trigonometry equation and you'll get that straight away. Very confusing. And then once you prove that, show that the motion is simple harmonic. So once again, differentiate that twice to get it into this form. If you want to show anything simple harmonic, get it into that form. That's not hard. I'm not going to go through that. Okay. Example 11, is there anything hard about that? Example 11, they haven't given you any equation, so maybe it's worth looking at. Let's just start it up to see how it goes. So it has a speed. So the speed is the magnitude of velocities, just 15. When passing through its mean position, so that means mean position is the center of motion. So obviously that's the greatest. When x equals 0 and acceleration 0. Find the amplitude of the motion. So find the extreme positions and acceleration in extreme position, given that the period of the motion is 2. So that means, so you got this, that means the period itself is 2. So that means from here we can find out what n is. So n is obviously then just pi. So what we know in extreme, at the center of motion, which we assume is x equal to 0 unless they said otherwise, we got the speed equals to 15, we got that. So basically the question you need to ask yourself is, if you know those facts, which one of the formulas do we want to use? Well, the answer is actually, I rubbed it off. Was it this? It was that, yeah? Yeah. It's got a minus? No, it doesn't have a minus. I believe that's it. Yeah. Yeah. So basically that's what you want to use, because you got the 15 squared. Can we apply it in that? Yeah. You got the n. You got the x. You can find your amplitude from there. Okay, so it's not hard. You just got to know which formula to use. Okay, great. We're speeding through exactly, right, example 12, exactly where I want it to be. Oh, this is so good. 5 minutes left. I'm giving a crash course. Example 12. Let's see if it's hard. Particles moving in a straight line. Velocity is that and that at distances 1 and 2 from the center of the motion. So I like to always draw the picture. So distances, so you got 1 meter, 2 meter. So clearly the center of motion has to be 1.5, yeah? Yeah. So the velocity is velocity at this point is root 5. Velocity there is 2. Length of the path, they go through a lot, but wait, hold on. Apparently the length of, what's the length of the path? Whoa, hold on. They got amplitude is 4, so the path is 8. Maybe I'm... Oh, no, sorry. You can't assume that. Oh, sorry. I misread the question. Yeah, because at distance of 1 meter, 2 meter, it doesn't mean it's on the other side of the motion. It doesn't say that. Sorry. All right. My bad. So basically then when velocity is root 5, the distance is 1. Velocity is 2. X equals to 2. So once again then you have v and x, so you want to use this form. Oh, not a. What is it? N squared, a squared minus x squared. So for this part, if you sub it in here, you're going to get an equation which is basically 5 equals to n squared a squared minus 1. And for this portion, you're going to get 4 equals to n squared a squared minus 4. And then from here, you want to find, like, see how these, it's common, it's some simultaneous equation. You want to divide these two equations so that these two cancels out. And then, yeah, it's got an equal sign on both ends. So 5 over 4 equals to a squared minus 1, a squared minus 4. Crisscross multiply, you'll get a equals to 4. Yep. So that way, how would we find the length of the path? Okay. Well, if the amplitude is 4, so if you look at it graphically, if the amplitude is 4, then that means the length of the path is 8 meters. Yep, because it's oscillating back and forth. So that's the extreme positions, remember? Extreme position, in this case, works out as 4 and minus 4. So the length of the path is 4 meters plus another 4 meters. And then it's just going back and forth. Okay, and then period of the motion, you're just finding n. So substitute a back into one of these equations, you'll get n equals to 1 over root 3. So the period is 2 pi over that, which is 2 pi over root 3. And there you go. Okay, nice and done. All right, easy, good job. All right, we did it. So next lesson, we're going to still be doing simple harmonic motion, but in the case where the center of motion is not 0, it's like some number. Yep. And hard exam questions on simple harmonic motion mostly comes from that. But yeah, you should actually now be able to do question, I wrote it down, up to question 29 of the exercise. But do make sure to thoroughly go through the examples that I just explained. Make sure you don't make any silly errors and actually able to do the full thing on your own. And then do the exercise questions up to 29. And then we'll go through just basically two, I think, how many examples? 3, 4, 1, 2, 3. 3 examples left. Maybe I might squeeze in an exercise question that may stand out, but I don't think there was anything when I looked at it. Yeah, maybe an extra exercise question. So 4 examples next lesson, and we'll finish the term with that. All right, thanks, girls. That was good. Woo! That's all right.